The first one we're going to be looking at is what happens if we have a breaking even problem. So anybody in here say when they grow up they want to have a business?
No, I want to be a nurse.
No one wants any business people? You're just going to volunteer for me? What do you want to do?
I want to have
What are you gonna
restaurant.
Okay, so Thomas wants to have a restaurant. Now, we're going to simplify your restaurant because let's be real, we're only in the first trimester of algebra. So your restaurant is now a hot dog stand.
Let's go.
Okay? So Thomas has a hot dog stand.
Thomas.
He sells each hot dog for, how gourmet would you like your hot dogs to be?
Pretty gourmet.
Okay, these are gonna be gourmet hot dogs. So he's gonna sell his hot dogs for
$12.
$12
That's a solid amount.
They're pretty big.
$4.25 each.
Outrageous.
He sells each hot
That's not
dog.
even enough. $12. That should be
It's a big
$12.
bucket.
Okay, it's fine. It doesn't matter. For $4.25, he has a hot dog stand. Okay. He purchases, right, because he's not magically going to have a hot dog. It's right. These are your notes, so it's up to you of how much you write this down. But he has to purchase the hot dogs to be able to cook and sell them, right? So he is going to purchase, and when I say purchase the hot dogs, it's just the price per hot dog with bun and everything because, right, we're just in first trimester of Algebra 1-1. He purchases the hot dogs for 86 cents each. I mean, it's a hot dog stand, not a restaurant, so he doesn't have a lot of operational costs. But he's gonna have to pay some electricity and hopefully to keep things clean and things like that. So he's gonna, some napkins maybe, things like that. So he's gonna have some operational costs of $57, ooh, that is not a 5, $57 a month. So we want to know how many hot dogs he needs to sell each month to break even. Okay, so he has a hot dog stand. He's selling each hot dog for $4.25. He purchases the hot dogs for 86 cents each. And he also has some operational costs of $57 a month. Okay, what is the goal of any business? To make money. Right, to profit, right? And if Thomas goes to the bank and he says, I want you to lend me $5,000 so that I can start my hot dog stand. Okay, I need to buy my hot dog cart, and I need to start with some buns and hot dogs initially, and I need a uniform, whatever. Okay, what is he going to have to convince the bank of for them to be able to give him the money?
As he's going to be able to earn that.
Is he going to be able to pay it back? Now, there are lots of things that go into that, right? Does he normally pay things back? What's his credit score? But also, is this business going to make money? Right? Is it reasonable for us to give him money for a hot dog stand if he's going to have to sell 5 million hot dogs every month to make a profit? No, right? They're going to, no, not going to do that. Right? So again, very basic here, very simplistic because we're just starting out our business as a hot dog stand. So let's talk about what we think we could relate this to. So we're not adding any new categories today. So if we go through the list of things we've talked about, is this a basic translation story problem like 4 more than twice something?
No.
No. Is this a pattern?
Yeah.
Yeah.
Like, can we do n plus 1, n plus 2, n plus 3 like we did with consecutive integers, or getting 13 more a week, or?
Because
No.
it says 0.
Well,
Okay, so you're right. This does say something of them each happening, but what does that each tell us? What was our rule yesterday if it was happening per item?
it tells us the cost, so would we need to do that?
What do we do if something's happening per item? What does that mean? It gets a variable. Okay, so we know those numbers are going to get variables, but that doesn't tell us how to set them up. Is this a total problem?
Yes.
Yeah.
Do we know the total?
Yeah.
What's our total?
57.
No.
No, that's his operational cost.
Oh,
you
so
paid.
let's go. No.
No, now, could we sort of reverse some wording in this and make it be a total problem?
Yeah.
Kind of. Okay, but it doesn't normally naturally just fit into this. Is this a comparison problem? Do we have two different things happening?
No.
No. Wait. Yeah.
If we have two different things happening, what are two different things that are happening?
Oh, you're
the
Ah, we're buying things and we're spending things. Right? This is a comparison problem. Right? We are spending money on some things and we are making money on some things. And for him to break even, what has to happen?
He needs to sell enough.
He needs to spend as much as he makes?
Yeah.
Do we see how this then fits into a comparison problem?
Yes.
Okay, there are two things happening. He's spending money and he's making money, and we want those values to be the same. Right? So now we'll go through and we'll start putting these in categories. So the 425, is that money he's making or money he's spending? Making. So we're gonna put that in our make column. 86 cents, making or spending? Spending, so we're gonna put that over here in our spending. $57 a month, making or spending? Spending. Okay, so now we also had the comment that anything that's happening per item gets a variable. So what appears happening per item?
The 86 cents. And the 50.
Is the 57 happening per hot dog?
Oh, no, it's
That would be a really expensive hot dog.
Oh, it's pretty low.
Yeah, that would be a gourmet hot dog.
It's a prime Frankfurt.
And what about an operation in between that 80.86H and 57? Why addition?
Or because it's saying like it says spend, so like naturally he would it's like it'd be like a total.
Right? It's the total amount that he spends. And so we're here. Total tells us to add. Sounds like good reasoning to me. Is this something we can solve?
Yeah.
Yes.
Okay, so let's start solving this. Are the variables on the same side or opposite sides?
Opposite.
Opposite. So opposite sides, we're going to have to get them together with the opposite sign. I mean, decimal fraction here, whatever. Doesn't really matter because what does this 16.81 say?
It's how
JJ?
much.
That's how much he needs to make to break even.
Okay, so he needs to sell 16.81 hot dogs to break even. Now, I don't think it's going to be a very good business if Thomas sells a hot dog but he's already taken a bite of it. Right? Probably not going to be super happy with a gourmet hot dog that is only 0.18 or whatever of a hot dog.
Yeah, I guess you could sell that, but like, why would you?
You gotta test the
Okay,
product.
so what is Thomas going to actually have to do
Round it.
to break even?
Round it to 17.
Okay, so we have to be a little bit careful of the word rounding because even if this was like 16.0001, he would still need to sell the 17 hot dog.
Yeah.
16 hot dogs wouldn't quite be enough.
Okay, 16.8.
Okay, so it's no rounding rules, it's just what makes sense. It's not reasonable to sell a fraction of a hot dog, so we need 17 hot dogs.
Yes.
I guess per month. We need 17 hot dogs per month, right? Every month he needs to sell 17 hot dogs to break even?
Less than one a day.
Right. So, do we think that Thomas has a pretty good business model here?
Yeah.
Just like any business, there'd be other things to consider, right? Are people going to purchase a $4.25 hot dog if right next door you can buy a hot dog for $2.50? Well, I don't know. How good is your hot dog? There's all types of things to consider. I mean, I personally really do like hot dogs, so I'd probably check you out if you had a gourmet hot dog. You'd need to have sauerkraut that could go on it, though.
That's flat. Why is that you? Disgusting.
Okay, next one we're gonna look at. Who is wanting a fancy electronic device for Christmas? Reese, what are you wanting?
Better phone.
Oh, okay.
Me too.
What type of phone do you want?
An iPhone 8. Yeah, that seems reasonable enough.
The P is actually
An iPhone 8.
6.
I'm 7.
An 8. 8's been out for like 3 years.
Wow.
Shut up.
I don't have enough
Lily.
money.
Sorry.
Okay, Lily.
Don't make fun of those.
How much does an iPhone 8 cost? 800?
Dang,
Seven?
It's
No.
not. It's not 8.
No, not.
It's 7. I bet it's 7.
We get it. Y'all are rich. Some people in this class
No, guys, up here. Up here, up here. Up here. Up here. Okay, who else wants a fancy, what do you want?
What the iPhone 11?
Oh, that's another phone. Okay, that's okay, now this will work.
Or I could put a MacBook because I also want that too. I've had the same phone for 2 years. Can y'all just go with me 1 minute?
Oh, life is so rough.
It is.
Wait,
It really is. It's the camera
wait
quality.
until you have to shell out the money yourself.
Well, I don't have a job.
The 11's only
What's an
$100.
iPhone 11?
I know, right?
I don't
What's
know
an
why the
iPhone
8's five
Isn't that thing with like
The 11's not $100.
I got an 11 at Verizon like 2 months ago and it was $11.
Dang,
It was $100.
guys.
Well, that's
I
because
saw
you have
these
like a plan.
telegrams.
Okay.
You traded it in, didn't you? That's what I have to do, but I'm just too lazy.
So, guys, if we look up here at this problem, first of all, I'm gonna tell you right now that I am taking something that is, can be more complicated, but I'm trying to put it into one that resonates with my students. Okay, we can start to see what's happening and going on, because it isn't intuitive to go this way to solve a problem like this. So you need to have a better understanding of money and tax and percentages and all those things. And then we're gonna relate it to some different problems as we keep moving forward, okay? Yes, Sam?
Is this assuming that it's every dollar cent is 7 cents?
So hang on. If we were to read a problem like this, normally, what the majority of my students would do is just say, well, I already know enough information just on my own that I can calculate a percent from these two numbers. And then once I know that percent, I can use it to find the sales tax on this. Okay, do you understand what I'm saying? So a lot of students would just go, okay, well, let me see what percent of sales tax is being used here. Or guess, let me see if it's 7% because I know that's Indiana sales tax or whatever. Okay, but again, I want to sort of step back from that and try and apply it to one of the formats that we already have, because there are more problems that you won't have this type of understanding on that you'll still need to be able to take this approach with, okay? So, if we go through our list of different types of story problems that we've talked about, is this a total story problem? No. Is this a basic translation story problem?
No.
Is this a comparison story problem?
Yes.
Well, yes. Why is this a comparison story problem?
Because they both want something.
Because we have two different situations happening, right? We have a situation for Reese, and we have a situation for Delaney. Okay, so we have situation 1 equals situation 2. Okay, so students usually recognize that, and they'll go, okay, I want to think about this as a comparison problem. And they'll start putting numbers underneath. So where does the 550 go? Reese. Where does the $44 go?
Also,
Where does the $9.99 go? Okay, and students usually get here and then they're stuck. Because the next thought that they have is, okay, well, what's happening per item? I should give something a variable.
Wait,
Yes, Haley?
is it, wait, never mind.
Are you sure?
Yeah,
You can always put a question or thought out there and we can
No.
see if it helps us move forward. No? You're sure?
yeah.
Okay. I mean, can we attach a variable to any of these?
No.
No. Okay, so before I just sort of straightforward tell you, if I were not to say that this was a comparison problem, Sam, you made a comment right off the bat, is this based on it being like 7 cents per dollar? Where did you get that 7 cents from?
Because that's like how you normally have to pay.
Oh, so you just did that with sales taxes in general.
Yeah. But you could also divide 44 from 550.
Do we agree that to calculate a percent, we would use division?
Yeah.
Why? Why do we use division for sales tax?
Because you're dividing like the money. Like,
The
why would
rate,
you
you get the
multiply?
rate.
Because it's a rate. Right? Whenever something is a rate, whether that's a percent, whether it's a like rate as a speed of miles per hour, that is division. Division is hard to read in a story problem. So you need to recognize that this is a rate. And with rates, we divide. So we want some division to be going on. Now, here's another factor that tends to help my students. If we can't assign a variable to an item, if nothing is happening per item, that's usually a pretty good sign that maybe there's a rate or division going on as well. Yes, Haley?
Oh, isn't the tax though happening per item?
Right, the tax is happening per 550,
No,
but it's not happening per a variable.
oh, okay.
What is this problem asking us to find?
how much tax will the
How much tax Delaney will pay? Does that have anything to do with Reese's tax?
No.
So I can't put an X over there.
Okay.
Do you get what I'm saying?
That's what I was thinking.
Okay, so it's not attaching to something happening per item in that regard, right? Tax isn't per item, it's a percent per item. It's a rate per item, and that means division. So what does 550 divided by 44 tell us? Do 550 divided by 44.
0.08.
And what does that 0.08 mean?
The tax.
The tax rate is 8%. That's where that division comes in. Does that make sense? Now that you see it like that? Is that a no, Ella? I couldn't tell from your face.
Wait, how do you guys all get 8?
How did you get
Yeah, I got
it?
12.5.
Do 550.
Divided by 44.
It's 12.5.
44 divided.
Oh, 44 divided by 5. Yes, that's what I typed in my calculator. I just knew which way to go and it doesn't matter.
It's 0.08.
So the correct answer is
8%.
Doesn't matter.
Wait, what is right?
Do 44 divided by 550. Right, there's our percent. But it doesn't matter which we put on top or which we put on bottom here. Okay, because here's how we're going to relate it. What does this 550 represent?
How much Reese is gonna pay?
Okay, right? This is sort of his initial cost. And what is this 44?
tax.
So what is Delaney's initial cost? So I'm going to put that on top. And what is Delaney's tax?
70.
Well,
We don't know.
Wait,
This
didn't
looks
we?
like something
But
like
yeah,
that.
this looks like.
Oh, no, that's what I was waiting for it to
Yeah.
happen. And then how many of us go, oh yeah, remember there was a person who was like 6 feet tall, and they cast a shadow that was like 3 feet long, and the building shadow is 12 feet long? How tall is the building?
Oh my goodness.
This is proportions. Proportions are comparison problems.
This makes me so happy.
Okay.
I love doing
So
this.
now
So
you just,
proportions are comparison problems. They fit into a category that we already talked about. You just have to recognize that the way two things are being compared is a rate, and therefore we use division. Okay, so I picked this problem because I knew this like percent would trigger division for you. And once we got far enough, then all my students go, oh, but wait a minute, I've seen this before. Okay, but I didn't want to just give you, oh, hey, set this up because this is what your teacher's already told you to do. Why are we doing it? Because we're comparing two things, right? And the way that they are compared is a rate, which is division, right? If you're doing a height per shadow, that's a rate. Miles per hour, that's a rate. Okay, so now once we're here, how do we solve this?
you multiply 999 and 44.
Right, we cross multiply. You can multiply either way first. So 550x equals some other large number. I don't know.
43,156.
43,156. Oh, 956. Okay, and then we'll undo multiplication with division. So do we see that connection now in there of what we were doing before? Yes. Did I divide wrong?
No.
Good.
But can't you just take 999 divided by 0.08?
Okay, yes.
Or
Yes, so
multiply the same thing?
Yeah.
yes, okay. So absolutely, guys, in a problem like this, yes. Are there other ways you could solve this? Yes, that's what I was saying at the beginning. If I wasn't like sort of funneling you towards this one direction, there are absolutely other ways that you could go about finding percents and solving. But I wanted you to see this setup and to pull that it was coming from somewhere, because we can do this when we're talking about tax, but can we do it when we're talking about a building height? Right? Those other shadow problems, no, not necessarily, and you'll sort of see as we finish up today and go into tomorrow, probably won't be until we start class tomorrow, that there are definitely situations that we don't just sort of have this simple workaround because we know more about percents, okay? So that's why I wanted to start here and sort of make that connection. What do we think so far?
Yes.
We're doing okay? So then here's what I want to happen. I want you to get